Hey everyone, and welcome to The Explainer. I am absolutely thrilled you're here today because we are going to demystify this unseen, incredibly fast-paced conversation that's happening right now between your web browser and the remote servers that basically run the internet. If you've ever wondered how bug bounty hunters actually find those hidden vulnerabilities, well, you have to start right here. At the foundation, you literally have to learn how to read the matrix of web traffic.
Picture this. You type a website address into your browser and you hit enter. Instantly, boom, a page loads. But what you don't see is the invisible flurry of hidden requests your browser just fired off simply to load that one single page. It didn't just ask for a website, It navigated domain names, resolved IP addresses, established complex connections, and sent some highly specific instructions. Today, we're going to intercept those instructions and figure out exactly what they mean.
All right, here's our roadmap for the explainer. First, we'll cover the hidden language of HTTP. Second, we'll dive into get, post, put, and delete. Third, we'll talk about the forgetful stateless server. And finally, we'll wrap up by equipping your web proxies. Starting off with Section 1, the hidden language of HTTP. To really grasp web hacking, you absolutely must understand Hypertext Transfer Protocol. Think of it as the literal spoken language that browsers and servers use to talk to each other. Every single time your browser reaches out to a server, it sends an HTTP request. And a huge part of this agreement between your client and the server is that an HTTP request must explicitly state its purpose. Servers aren't mind readers, right? Your browser has to tell the server exactly what action to perform, and it does this using specific request methods. You can basically think of these methods as the action verbs of the internet. Moving right along to Section 2, get, post, put, and delete. We're going to run through these HTTP action verbs like rapid-fire flashcards, so try to lock these into your memory. First up, we've got get. The get method does exactly what it sounds like. It retrieves information. It's asking the server to go get a resource and send it back to you. But here is the critical part. Get requests should never, ever alter data on the server. If you visit a friend's social media profile, a GET request retrieves their profile name so you can read it, but it absolutely should not update or change that profile in any way. Next is POST. Now, if GET is just for looking, POST is for doing. The POST method invokes a function on the receiving server, which triggers backend actions. When you fill out a form to register an account, or publish a new comment, or process a payment, your browser is sending a POST request to make those things actually happen on the backend database. Then we have put. Put is kind of like post's close cousin. It also makes things happen, but its specific job is to invoke a function that refers to an already existing record. So if post is creating a brand new blog post from scratch, put is the action your browser uses when you want to interact with and update a blog post that's already been published.
And wrapping up our core verbs, we have delete. This is definitely the most straightforward one of the bunch. It simply requests that the remote server delete a specific resource identified by a specific URL.
Now, this direct contrast between get and post, it's an absolutely crucial concept in bug hunting. See, browsers automatically send GET requests whenever you click a basic link. So if a lazy developer decides to build a website where a GET request actually changes data, like say deleting a user account just by visiting a specific URL, that is a massive security vulnerability. An attacker could trick you into clicking a link, your browser sends the GET request, and boom, your account is just gone without you ever even submitting a form. Which brings us to Section 3, the forgetful stateless server. Now that we know how browsers ask servers to do things, we really need to understand a massive quirk in how those servers actually listen. Here's the wild thing. HTTP is inherently stateless. By technical definition, stateless means that every single HTTP request sent to a server is treated as a brand new, completely isolated event. The server has zero memory of any prior communication. Imagine trying to have a conversation with someone, but you have to completely reintroduce yourself and explain your entire life story before every single sentence you speak. That is exactly what your browser is dealing with. It's literally like what Adam Sandler has to do for Drew Barrymore every morning in the movie 50 First Dates. The server wakes up with total amnesia for every single click you make. It is incredibly forgetful and honestly a bit of a nightmare for web developers to work around. Because reloading all of your information with every request would be unbearable, human engineers created some pretty clever workarounds, things like cookies and basic authentication headers. When you log in, the server hands your browser a tiny little file called a cookie. Your browser automatically attaches this cookie to every single subsequent GET or POST request it makes.
This basically restores the server's memory, allowing it to say, right, this is Jame, she's already logged in, so you don't have to retype your password for every single page. And that takes us to Section 4, equipping your web proxies. It is time to learn how to actually intercept this hidden traffic. All right, let's ramp the energy back up. We've covered the theoretical language, the action verbs, and the stateless amnesia of the internet. Now we're getting into the practical tools. It's time to put on your bug-hunting X-ray glasses. To find real vulnerabilities, you can't just rely on what the website visually shows you on the screen. You need a tool called a web proxy. A web proxy sits right in the middle, between your browser and the remote server. It gives security researchers the absolute superpower to freeze time, read these hidden HTTP messages, and even change them before the server ever gets a chance to see them. So what are the essential proxy tools you need to know about? Well, the absolute heavyweight in the industry is Burp Suite. It's a massive integrated testing platform that most professionals use like 90% of the time. But if you want a fantastic, free, community-built alternative, OWASP Zap is incredibly powerful. There's also Charles, which is really great for monitoring, and Fiddler, a nice lightweight option if you're a Windows user. Let's look at how this builds into an actual workflow. Step 1. You click a button, and your browser fires off an HTTP post request. Step 2, instead of going straight to the internet, your proxy, like Burp Suite, intercepts that request and literally pauses it right there on your screen. Step 3, this is where the magic happens. You, the hacker, can now modify that request. You can change your user ID to someone else's or swap a price from $50 down to $0. Step 4, you hit forward, and the altered request finally reaches the server. And because the server is stateless, it just blindly processes whatever you sent it, completely unaware that you tampered with a message in transit. By mastering these HTTP methods, understanding that stateless amnesia, and wielding a web proxy, you are literally pulling back the curtain on how the internet functions. So I'm going to leave you with this final thought. If you booted up a web proxy and paused your browser's traffic right now, what invisible conversations are whispering on your machine? What hidden GET and POST requests are flying out into the void? Get out there, set up a proxy, and find out for yourself. Thank you so much for joining me on this explainer, and keep learning.